Hello and welcome. I'm very sorry that I didn't answer any of your questions on Slido after I talked about Slido. Well done, Chris. They said they're going to send them to me and I'm going to answer them on Twitter in the next few days. So next up, and I've been talking about Slido, we have Eyal Felstaine, from the CTO from Amdocs, and he's going to talk about democratizing AI even more than I talked about because he has like information about it. But before he goes on stage, he had a question for us that we put on Slido so we can quickly get an idea of what's going on in the room and what people are thinking. Can we switch to that question quickly? If you committed a crime, whom would you prefer to be judged by? Should it be a machine learning bot or should it be a human? You don't have to say which crime, by the way, so it's totally anonymous. It's also fictitious. But it's an interesting question with lots of loaded information in that. So by now we're 50-50 with 4 people going for it. I think we're not starting until we have a sample size of 30, and then you will actually have an idea who you're dealing with in terms of the audience here. Here we go. A human is winning. Machine learning bot is catching up. And more, and more. Okay. I guess I helped the audience by having all my keynote about humans rather than machines. So maybe I was tainting your data here. But so far we got 75% of people say they would rather have a human judge them than a machine judge them. So Eyal Felstaine, please tell us what you think about that answer and what else you can talk to us about democratizing AI even more. Welcome.
My name is Eyal Felstaine. We touched that question very soon, but before I introduce the company, the 2 logos here, the Linux Foundation and Amdocs. Amdocs is the company I work for. It's a 27,000 employee software and services company which is doing everything software for the telecom business. We have AT&T as our customer. In the US, we have TAG in here. Deutsche Telekom, France Telecom, every major T-Mobile, every major operator you've heard about in the Western world is pretty much doing business with us. The other thing I want to talk about is Linux Foundation and open source. And that's the other role I do, which is being the governing board member on a Linux Foundation Deep Learning Working Group. So let's start with a small discussion about what is open source and how it's acting as a tsunami that is changing the industry. So we all know that on the left side of this slide, we see the traditional approaches. So we have SQL. Traditional companies are making money out of SQL. I think Oracle is the leader. And non-SQL database, which are open source, such as Hadoop, are changing that industry and becoming more and more prevailing. Cloud, for instance, a leader in the non-open source cloud is VMware, for instance, is being disrupted. There's free cloud, open source cloud, KVM, OpenStack, Kubernetes, all the names we all know about. Operating system, at least for servers. Today, most of the operating system for servers are Linux. There used to be Solaris, there used to be, I think Microsoft was doing operating system for servers, but today Linux is really leading. And with artificial intelligence, there's a very big question whether the artificial intelligence stack, machine learning stack, will become something that is based on open source, because at the end of the day, open source, in addition to being free or at least cheaper, usually is a combination of effort for many companies, and at least in the Linux server, it's proven to be superior than the proprietary closed solution. So this is one of the themes from the talk today. The one thing that we need to understand that writing open source politically is not a simple thing. Why? Because think about Hadoop, which is a massive database. You see on the slide, a bunch of companies who are offering code that will work on as Hadoop. And these companies, some of them are pretty much competitors with each other. But to some extent, they need to actually have something that will actually work, right? So usually there's a governing organization, such as the Linux Foundation or the Apache Foundation, and they govern the interaction between these, in some case, competing companies so that it will work together. There's role, there's a contributor. Everybody who can offer his own code. You can sit in a garage and decide, I'm going to be a contributor for Linux and send your code. But it doesn't mean that the Linux Foundation will accept it. Somebody whose name is a committer, whose role is a committer, will check your code and choose the right code that fixes a bug or build a new model. And there's the technical steering committee inside open source organization, which actually decides upon the roadmap and how it moves on. And there's similar ecosystem around OpenStack, and there's similar ecosystem around Linux. And in Linux Foundation, Linus Torvalds is actually heading the technical steering committee of Linux. There's a bunch of contributors. Some of them are competing against each other. And they work but there's a governance system that doesn't allow one company to overrule the other. In fact, the bigger rule is if you're willing to put resource into a feature or a project, we're not going to stop you. Because you're putting your money, your corporate money into it. Many of the contributors and committers work in companies. They don't really... Linux today is no longer developed by people that do it as a part-time. This is people that have a day job in IBM, Red Hat, and so forth. Actually, it's the same company today. And when Red Hat decides to invest in a module, or IBM decides to invest in a module, nobody's going to stop them doing a different module. What the Linux Foundation is in charge of is the consistency and coherency of the code. So before we dive into open source, I want to get us all aligned on what is machine learning. And I think it's very important that in the next 5 minutes, even if you don't know what is machine learning, you will be able to understand it from the next 5 or 10 minutes. So you should feel very comfortable, whatever knowledge level that you have. And even if you do, I think it's even going to add more value. So let's take the case of X-rays, OK? You go to a hospital, you fell on a bike or something. You go to the hospital, they take an X-ray. Then they send it to analysis. They send an image. It's a very detailed image of your X-ray. It goes to analysis. It could be a person inside the hospital. Like in the US, it will be sent to India because there's medical staff that are all the time on call and cheaper labor and so forth. But at the end of the day, somebody's going to look at the X-ray and would say something like, hey, you have a fraction in the third rib, or the clavicle is broken or fractured, or everything is wrong with this guy. The skeleton is fine. Okay? That's going to be a human deciding. Okay? Now, with machine learning, let's assume that you have millions of pictures like that, coupled with millions of prognoses, right? Fracture on the third rib is a prognosis. In machine learning, we call these labels. If you have millions of pictures and millions of labels, you have enough data to train the machine to do it automatically. So what you do is this. First thing, you take one of the existing machine learning algorithms. There's this library called H2O. There's a library called Caffe. There's a library called TensorFlow, which Google is very excited about. There's a scikit-learn. You take one of those libraries, you do some configuration, and then you tell it, here's the data, Here are the label, the prognosis of the doctor. You throw it into the machine learning, and eventually you get a trained algorithm here, which gets a picture and gives a diagnosis. Now, I want to explain one very important thing. With machine learning, the trained algorithm doesn't know. He has a total bottom-up learning process, which means he doesn't understand anatomy at all. He doesn't know whether the human skeleton is built of plastic or clay, or it's some sort of liquid, or it's what. He doesn't know anything about all that. All that he has done, he had, the monkey, if you may, had a picture and a prognosis, and a picture and a prognosis, and after millions of them, he's going to make the right decision. And that's machine learning, okay? It's where you teach the machine things that it learns. I'm going to give you another example of machine learning. I see relatively many young faces in the audience, so I have interesting news for you guys. When you send a resume today to the big multinationals, in 75%, a human will read the resume. The first time you send it, you haven't had the first interview and so forth. He will read the resume and he would say something like, let's go to the interview, let's move to the next step. In about 20 to 25% today, human is not going to be involved. What's going to happen, well, in the future it's going to be almost 100%. What's going to happen is very similar to the X-ray story, okay? So we have all of this data, okay? It actually sounds frustrating. How could I'm sending my resume to a company with there's a story here, I was born and at this university, and nobody's reading it. It's a fact, right? Because it goes through the same process. Resume, which is the X-ray, the data. Label, which means, well, in the past, a human would accept or decline to move forward. We are training the algorithms. And after that, we have eventually a trained algorithm, which gets a new resume and gives an automatic AI decision about what to do with this recruitee. Okay? And we will see this coming more and more in many more models. There's something called artificial intelligence bias. And the thing is, we tend to say the computer is always right. Well, no, we tend to say the computer is unbiased, okay? So let's think that about an organization where the human people who make this decision are saying something, that they have this bias where they see somebody living in a zip code that is not so bad neighborhood, or somebody has a last name which could indicate some ethnicity, or that he's an immigrant, or he's color and all that. And that human is making a decision. Now you feed all that data to the machine learning, and now the machine learning is rejecting all the minorities. But people tend to associate the computer with being not political, or not biased, or not against a racial thing. So that's something that is very important when we train a model. There's a new domain which is called explainability in AI, which says something like, let's explain to ourselves why did we reject this candidate. And in some cases, if it goes to the zip code or to the last name, not to the university, that's fine, to the last name, then you may decide to erase the last name or the zip code before you give it to the AI. And now the AI does the learning, but it doesn't take care of anything that could look like color of a human and so forth. So I think by this, I pretty much explained what is machine learning, and that gives me back to the question I asked, which is, would you be, let's say you committed a crime. You murdered somebody, okay? First time. And you know, it's like, you know, like an X-ray. Eventually, when the judge look at the case, he says, is it the first time? Did you ever, you know, first, you have no criminal record. It's the first time. You were drunk or not, under influence or alcohol, any, you know, with intent, without intent. Eventually, there's a set of elements of data, and there's a judge deciding. So I heard that 75% of the people said that they would be judged by ML, if I understood correctly. And if that is the case, I think you made a good decision, because at least when you go to court and you're going to have your sentenced, then there's going to be something that is going to be very predictive, in the sense that you're going to have a very fixed sentence. A human will not show you more compassion than the machine learning, because the machine learning is already learning based on the compassion of the other judges. But the human could be unpredictable. For instance, it is proven that if the judge is male, in the case of assault of women, then the sentence will be very negative, much more severe, if the judge has daughters. And if the judge has no daughters, or only boys or none, it will be less severe. Proven in 2 orders of magnitude. Or if the judge lives in a town where the football team has lost in the same week, the sentence could be much more severe, okay? So that's facts, okay? So with ML, with machine learning, there's a robot that learns all of the attributes, and it will actually give the sentence. The story with the resume is a story of machines that are giving a sentence already to the resumes that we sent. Okay, so what is Linux Foundation Deep Learning goals? The Linux Foundation is a non-profit organization, a very large organization, by the way, in the US, with more than 200 employees. And the deep learning group inside Linux Foundation is actually working on making artificial intelligence an open source project. I think there's a lot of value to open source. The price is one of them, but it's not the most important. I think the fact that you can, when you're using open source, you own, you can always modify. You're not stuck with one vendor at times, and I'll get to it. So we want to open source artificial intelligence, machine learning, and deep learning. Now, the distinction between artificial intelligence, machine learning, and deep learning is the following. Everything I explained so far is machine learning. Everything where the machine gets all of those examples and the labels, that's machine learning. Artificial intelligence is broader than machine learning. It's machine learning plus everything that looks like the computer is smart, okay, and making human decisions. So a chess software, which was developed 25 years ago, has nothing to do with machine learning, that's AI. But machine learning, like the X-ray thing, is machine learning as well as AI. So there's machine learning is included in AI. Deep learning is one type of machine learning, which is its subset of machine learning, and that's neural networks, which is software that is imitating the human brain. I'll talk on the first project that we started working on with Linux Foundation Deep Learning. That's Acumos. That's a project that I'm investing heavily. And I'll explain to you what is the story with Acumos. It's kind of a marketplace, like an app store for machine learning models. You're going to understand it very soon. But let me explain to you what is the problem of startups when it comes to machine learning. So startups So the big companies, Amazon and Google, they have tons of data, okay? So think about it. If you are human, since you're human, Google knows about your health because they have the Google Watch. They know where you are because Google Maps. They know about the photo you took, the email you've read, whether you are sending email while you're driving or not. They know about your network consumption, what you search. They pretty much know a lot, okay, everything almost. If they want to be an insurance company, then that insures car drivers, they can know everything about you as a car driver. Did I drink alcohol last night? They know it from Google Health. Am I a good driver? They know it from Google Maps. Do I text and drive? They know it from Android. So they know everything. They have no problem to monetize on their data because all of the data they have is in a lake. And Amazon is a similar story. But when you are a startup, let's say you are a startup in the medical field, and you want to have access to all of those X-rays, do you think that it's easy for you as a startup to get all of the X-ray from a certain hospital? Not so easy, because those X-rays could be connected with individual people, or even the prime minister, or the president, or the head of the army, or something like that. So if you're not Google or Amazon, or one of those big Netflix and so forth, you are very siloed into having a very small amount of data. And remember that data is the new gold. Why? Because if you have millions of X-ray, you can make a machine that understands X-ray. So this slide, it looks complex, but it's a really simple slide. I will explain it very easily. It says the following thing. It's a recipe for creating a machine learning algorithm. Step 1, 2, 3, 4, like cooking, okay? Step 1, take a machine learning algorithm. TensorFlow, scikit-learn, H2O. How do you choose the machine learning algorithm? We'll talk about it later. There's dozens of algorithms, dozens of methods, clustering, regression, convolutional neural network, simple neural network, what have you. How do you choose the actual model? That's a good question. We'll take care of this. But so that's one thing. You take the model, and then you train the model, or training meaning giving all of the pictures of the X-rays and the prognosis on and the label to the organization, to the hospital, okay? And the hospital is not going to give you the X-ray, right? Because this is sensitive personal information. But inside the hospital IT, it can train the model. And eventually, once it trains the model, you're going to have something which is called a predictor. A predictor is a trained model. Now, the beautiful thing is that you can pull out the predictor from the hospital without taking the data of the people and the X-ray of those people. So the predictor contains the skill to get a new X-ray and get a prognosis, but it does not remember what were the million pictures. It's like if you've seen some artificial, some movies, sci-fi, science fiction, then you would see somebody who has been done training, and now he's like a super warrior, and he's like, karate and all that, but he doesn't remember where he was trained, how he was trained. He only remembers the skill. And what's interesting with this is that legally, it is possible to take the predictor out of the hospital and commercialize it without, because the lawyers understand that the model forgot all of the pictures, forgot all of the X-rays. Now you go to number 3, and in number 3, there's a marketplace of predictor because one hospital put a predictor, the other hospital put a predictor. You can choose you can buy the predictors, right? Because they have value. There's a value in a software that can examine X-ray, right? So now there's going to be an app store or a marketplace. That's step number 3 for predictors. I'll repeat it again, so don't worry about it if you didn't understand everything. Step 1, the developer selects a model, which is a big data scientist problem. We'll touch that. Second thing is you choose in which hospital to run it. One hospital is asking you 5 cents for 1,000 picture. The other one says, I have a very good quality prognosis. I'm going to ask you 8 cents per 1,000 picture. But eventually, you choose whichever you choose. You run the model, and you export the trained model. You export the predictor outside the organization. And now, in step 3, there's an upload. There's an app store with models, okay? There's a model for image classification, ready. It's a finished goods. It's a product. You can buy it. And there's a model for face detection. And there's the model for customer segmentation, and so forth. Customer segmentation is in marketing where you actually segment customer based on. The last and fourth phase of Acumos is where you take those models and chain them together to create the whole thing. We were talking about X-ray, but when you talk to the doctor, X-ray is not enough. He needs to know your cardio data. He needs to know your blood. He needs to know your EKG. All kind of measures to your health, and only the X-ray is only part of them. So you can actually take several predictors and make one big solution out of it, and that's the essence of Acumos. And I think I want to wrap up Acumos and move on to the next to continue to talk about open source. But the story with Acumos is that it's a means to actually create models from organization, and the bigger value is that you do not have to take the data out of the organization, because especially today in Europe with GDPR, you cannot take people's data for a good reason, by the way. You cannot. But if you trained and get a skill based on the data, you can take out the skill, and that's how companies can collaborate between each other and get value here. I'm going to give you an example that we did with AT&T, our customer. A company like AT&T, they have 80,000 antennas around the world. And, 20 years ago, they used to send a man in a van, and he's going to climb on the antenna, and he's going to see if something is broken, or dirt, or pigeons are destroying it, or what needs to be fixed. It's part of maintenance. And about 6 or 7 years ago, we started using drones. So we are sending drones, and instead of sending a man, there's a drone, and he's looking around, and he's sending a movie of the antenna. But then we said to ourselves, why just do it with the movie? And who's looking at the movie? There's a human looking at the movie and seeing, this part is broken. I need to send a special part to a special antenna and to climb up and fix it. So the thing is, if that human could be replaced by a machine, okay? So what we did, we started with looking at the same thing, training set, which is the video, prognosis, which is the decision to replace the part or clean a part or whatever it's here, doesn't matter. That's another decision, right? We take all of that, and automate the whole thing. And that works, that absolutely works with Acumos in a sense that Right now, it's the machine, it's the AI that is making the decision to fix elements in the towers of the telecom. Okay? And the more interesting thing is that this software is being sold to other telecom mobile operator in the world. Some of them are competing to AT&T. AT&T is making money out of it from selling them to competing companies. And remember, the model, forget about the antennas. These antennas are a homeland security, critical assets. You don't want everybody to know how to destroy the mobile telecom system of a country, right? But the predictor doesn't know about the towers anymore. It only knows the skill to identify the towers. So that's the first project of machine learning that we are doing with Linux Foundation. But in order to fully understand, totally understand the landscape of machine learning, we have to understand how to operate a machine learning. So with machine learning, we talked about training, we talked about predictors, but in order to do the training, you have to have the inputs. Let's remember the case of the resume, okay? So you have the resume coming to, we're sending our resume to some company. The company wants to recruit people. It extracts the picture because one guy is sending PDF, the other guy is sending Word document, the other one is a scan of some fax machine. We are extracting the features. We are arranging them. Remember, we were talking about taking out the zip code and the last name because we don't really want to use that, the first name and last name, because we don't want to use stuff that could be racial or socio-demographic in our organization. And we feed it into the machine learning organization with the features and the labels, and then we have a classifier or a predictor that knows how to do that. That's step one, a very, very tedious process. If you work in an organization that does ML, machine learning, there's the data engineer who's doing data ingestion. He's taking all the data, analyzing it, deciding which part should be removed, if there is some data elements that should be taken out of the equation because they are not relevant or broken or not working. And there's a huge, tedious step before step 2 starts. And that's the training pipeline. After you do all of that, you work on the data, you analyze the data, you decide which parameter should be the label, which parameter should be the training set, and so forth. You run it to the training, and in step 3, you serve it, which means in step 3, you already have a predictor, and you deploy the predictor. There are 3 types of people in every machine learning project. 3 types of, well, there's many types of people, but there's 3 roles. The first role is the data scientist. This is the person that clearly makes the most money in the organization because usually it will have to be a PhD in statistics or today PhD in machine learning. And he has very good mathematics background. And he's the guy who analyzes the data. He's the guy that knows which one of the algorithms to use, whether convolutional neural network or regression or clustering or whatever algorithm to use. Data engineers are smart people with computer science background, and they take care of the first step, this one, the top one, the data pipeline. And the third step is the business manager, and he is going to be in charge on the KPI, on the key performance indicator. He would say something like, hey, so I want to have I'm getting 40,000 resumes a year. For this role, I want to have these skills from the employee, from the candidates, and I want to move to the next step only 500 because we are eventually recruiting 100. So the business manager will actually articulate what the business requires. The data engineer will be in charge of the software. And the genius data scientist, which is very hard to recruit position, it's very, very hard to find today in the market do data scientists because they are all being grabbed because there's so little of them. And the thing is, there's a new phenomena of saying, why do we need to have, it's so hard to get a data scientist. One of the important tasks that the data scientist would do would be to choose the algorithm, that to train, and to see how it runs and so forth. Why don't we have an automatic data scientist? There's even a term called data scientist as a service. I'm not sure I like it because it's been used today for 20 other things, but the idea is to automate the labor of data scientists. Let me explain to you what do I mean by that. Okay, so you have automatic machine learning, right? So you have, remember, think about the X-ray, okay? You have a big asset. You have all the X-ray, your hospital, you have millions of X-ray, you have the best prognosis, you have the best doctors. You think you can make a lot of money out of it, but you don't know how to run it. Neural network, convolutional, and even the neural network, you have to configure them because there's the amount of layers in the network, the connectivity between the synapses. There's a lot of permutation here. Who's going to do it? Data scientist. How he's going to do it? He's going to work on this for 3 months, which are very expensive, with a team, and every day he's going to run a batch, look at the results, have a teamwork, graph, PowerPoint, and all that. But the other approach is say this. I have 1 million pictures. Let's take 50 algorithms, 50 potential algorithms. One of them is going to be good, right? Survival of the fittest algorithm. I'm going to train those 50 algorithms, 50 models, with not million, but 5,000 examples, and check how are they doing with another 1,000. So I processed 6,000 elements. Again, I trained each model, linear regression, convolutional neural network, simple neural network, and so forth, with X amount of layers in the network. I trained each one of the models on the same 5,000 element. You know, it's something that happens after 3 nights. It runs in the lab. Or in a cloud, it can run in, if you throw it in Amazon, it can run in a few seconds if you use many, many compute nodes. And eventually, you're going to come up with a score of each one of the models. And you say, okay, so model A doesn't work because it's not starting to really create a good prognosis when I use it against new data elements. And model C is even worse. And model N is 0.72, not so good. But there's 2 models, model B and model D, 2 types of algorithms. TensorFlow algorithm 5 and Caffe algorithm 7, which are doing a good result. So I'm going to continue to work with them on a few other examples until I reach the model. So essentially, in this approach, we are pretty much automating the work of the data scientist, and I think this is where the world is going when it comes to machine learning. The last slide of my deck is not designed to scare you. It's actually designed to explain to you the complexity of something. You don't really need to understand everything on the slide I'm going to present to you right now. So actually I'm showing it from the bottom up. We show step 1, preparation of the data. Step 2, training of the model, whether it's by humans, data scientists who are sitting and setting up the parameters, having meetings and all that, or whether it's by an automatic algorithm that choose the right model or the right algorithm based on some experimentation, and then the rollout, which is the serving of the machine learning predictor. So what I'm sure, so as I said, this slide, if you don't remember this slide, you shouldn't feel bad about yourself at all, but it's trying to explain the layers here and how they're used in open source projects. And many companies use many of these elements. So initially we have the hardware, and we have NVIDIA, AMD, Intel. Above that we have cloud, which is the cloud providers, Amazon, Microsoft Azure, and so forth. But above that, you have the analytics infrastructure, such as the Hadoop to contain the data, Kafka to move the data around, to move the communication around, and so forth. And the machine learning libraries are all open source libraries, such as TensorFlow, Theano, H2O, and so forth. They're all open source. They're all really basically coming from universities. They're coming from University of Montreal, MIT, and so forth. These are the models that you need to choose in order to train. And above that, you have the higher level tool, which are used in order to actually develop the algorithm and create it and choose the right model. These are, some people call them machine learning ops, like DevOps. It's machine learning ops, very, very similar. So to summarize my session, I have 5 minutes for questions. To summarize my session, I think machine learning is a very delicate thing. In the previous session, I was talking about looking at people and understanding what is their sexual preferences, what race they are coming. You know, it's a domain. I'm not a machine learning psychic or mystic or something like that. I look at it as a very scientific thing, but we are given a huge power as humans, and with machine learning. My gut feeling is that it is for the benefit of all, that at least there's going to be open source about machine learning, because at the least we have transparency into the algorithms, not the software, not the data. Of course, every organization owns its own data, but at the least we have transparency into that. And I think it's a great thing. And by this, I understand that we have questions, or we have a tool to get questions. So if there are questions, I would love to answer them. Thank you very much. What?
Thank you, slide.
Thank you.
Excellent. We have a few questions, so that's good. We have a bit of time, about for 2 questions, and then we're going into a break. I also should remind people that there is another stage where the MC is much more organized, and there's also great talks, so you can go on both of them. And also, when there's later on lunch break, I was asked to remind you that there's lunch here, but also downstairs, so no picking from other people's plates. There's enough for everybody. So the questions we had, a few of them were actually quite interesting. Others were a bit snarky. Can we download the slides somewhere?
I'll put it on a simple question. I'll put it on WeAreDevelopers website. I send it to WeAreDevelopers, you can download it.
Cool. Biggest question, how does Linux FDL compare to OpenAI?
I think we want to be, I think we want to be the umbrella for all projects, because we believe and we see that in the long term, some projects continue and some projects disappear and they don't. For instance, FreeBSD, great version of open source operating system, did not continue, although it was very good. So out of this algorithm, out of the, Out of the algorithms I show you in the last slide, the scary slide with so many names of open source projects, some of them will not continue. As far as I understand, Linux Foundation wants to be the umbrella to everything open source AI, including OpenAI. We want it to be part of the umbrella and to see which project will get traction and which will not.
Okay. That's an interesting one for medical applications in machine learning. Would a human always be needed due to liability issues? A bit like self-driving cars need a non-sleeping driver.
Yeah, so I think you said in the previous session, and I agree with that, that I'm not going to be replaced by machine learning if I'm doing something interesting. If I have a very tedious job that is not very creative, and I'm just, getting a paper, doing something about it, filing in the cabinet, probably I'm going to be replaced with the machine learning. If I'm driving a car in a relatively very regulated environment, not so many, like not in Istanbul, for instance, which is really hard to drive a car, right? Then or Tel Aviv, then I can be replaced by a machine. So the question is, liability issues is what we as humans decide upon, okay? It's our legal system that decide upon. If the legal system will understand that it's better to have accessible machine learning than to have, it's not easy to get to a doctor in every country today. If you have something in many countries, in many situations, you can access a doctor. So is it a better thing to get machine than a human? If it's much more available, I would argue it is. So if I'm the regulator, I would not put machine learning medicine at a bigger liability. But at this point, machine learning is not even close to replacing doctor totally, only to empower them.
I think an interesting fact there is as well that in America, people have up 3 to 4 minutes time with a doctor at a time. Exactly. So if a machine learning algorithm could whittle down the information, then probably doctors would have more time and doing less research.
I totally agree.
So the last one before we go into a break, I like that actually. It lost. We lost it. Okay. I like the question about Amazon and Google, if open source is even possible, or if there's always a hidden agenda, especially as it didn't mention Microsoft.
What did you say?
But yeah, there. Can open source be developed by Google or Amazon? Isn't it always for purpose, which we don't know yet, so it's not open anymore? So what's the fallacy in there?
So I can tell you from our experience, many of the open source components are developed by Google and Amazon and Facebook and Microsoft. They are coming from those Kubeflow, which is a huge tool to help with it's a very important tool to do open source batching, or to do machine learning batching. Is developed by Google. It's coming open source. And there's ONNX, which is from Microsoft and Facebook, I believe, right?
I think so, yeah.
And it's becoming part of open source. So all of those companies are contributing all of their models to open source.
So basically, we don't care about the hidden meaning as long as it's open source. You can always fork it.
Yes, we don't care. It's open, it's transparent.
Excellent. I think there's people screaming outside, so we're out of time. Do you have time to answer the question if the Slido people would email them to you?
This one?
The ones that haven't been answered.
Yeah, why not?
Okay, the Slido people will email your answers, and now you have to do it. Haha. Sorry. Okay. Well, thanks again for this. This was great.
Thank you very much.
Eyal Felstaine, everybody give a hand. And now we got a break.